Hi, I'm Jonah Wade, and this is Physics 2212, Lab 2, Lines of Charge. So to begin, the purpose of this experiment was to use charge tape to compare the point charge model to the lines of a computational charge model. This was done by dividing the tape up into segments and treating each segment as a point charge in order to approximate a more accurate charge quantity for each tape. And the fundamentals used in this experiment were Coulomb's law, the formula for the electric field, the formula for the gravitational force, a derived charge formula, Newton's second law, and the polarization of neutral materials. The results of this experiment show that the magnitude of the electric force was 1.96646 e to the negative 3 coulombs. The magnitude of the gravitational force was 1.9362 e to the negative 3 coulombs, and the superposition provides a more accurate result than treating tape as a single point charge. The procedure of this experiment used a lot of the same processes as Lab 1, and it involved one piece of slack U-tape stuck between two neutrally charged books. Another piece of U-tape was held below and moved closer to the suspended tape B, until that tape B began to move, or float. And the distance of the two pieces of tape were measured, and mass and the dimensional constants were recorded as well. Now, to calculate the Q value, I used the two formulas on the screen here and got a Q value of 2.32 e to the negative 8 coulombs. And doing it computationally, here is my glowscript code. As you can see in the beginning, between lines 40 and 60, I introduced the electric field. Then I defined the line charge and broke it up into n segments. I then created the models of the lines themselves. And then I created a for loop as the code is approaching the bottom of the screen and entering into the next screen. I created the for loop to determine the net electric force. And then finally, I determined the gravitational force and created the appropriate vectors. As you can see, here's a visualization of the code that was just shown on the screen. It shows the appropriate electric force and gravitational force values, and through guess and check, I was able to come up with a Q value of 2.11 e to the negative 8 coulombs. Now, in this experiment, there were some assumptions made. Each piece of tape was assumed to be the exact same length and of the exact same charge, when in reality there were likely some discrepancies in the charges of the two pieces of tape. Air resistance was also completely disregarded in this experiment, and it was also assumed that no charge was lost while handling the tape, when that is likely not to be the case. So as a result, those are likely factors that produce some errors, as well as the fact that all the physical measurements, which include the measurements of the tape lengths themselves, as well as the distance between the two pieces of tape when the piece of tape B began to float. They were all done by hand, and we're just taken with the naked eye, so they are likely inaccurate. Now, this experiment does provoke some what-if questions, and the first one here is on the screen. What if it had been modeled that each piece of tape was a single charge like it was in Lab 1, and then as you can see, I have compared the results I got from Lab 1 to the results I just got from Lab 2. Lab 1 assumed that the pieces of tape were singular point charges, and Lab 2 obviously did not. It assumed it was a line. And as you can see, Lab 2 was much closer to the value in the calculations I got earlier. And these likely differ because Lab 2 is much more accurate, as a piece of tape is much closer to a line than it is a singular point. And so therefore, you're getting a different value and a much more accurate value. Thank you.